Uh, Attendance policy, just to do a recap. Number one, okay, even if you never attend lecture ever, the biggest damage is what? How many points can you lose? Grade and a half, excellent. And if you buy the lab manual and you get all the extra credit, that goes down to about a grade, right? So the biggest damage is about a grade to a grade and a half. And honestly, that's a good deal, right? So I get these emails from students who are like, oh, the commute is bad, or I only have, this one thing this day. Sucks. That's a shit schedule. My condolences. But, the reality is back in the old model was attend if you want. There will be exams, right? And we all know that there's a few people in the world that they seem like they don't put forth any effort at all, and they come in and they ace the exams, right? We know people like that. Now, there are always a few of those, right? But the vast majority of students are not those people. Those people are very unusual. So all those people who couldn't attend class this year, they wouldn't have attended in a past year, and they probably would have done a lot more damage to their grade than, one letter grade. Okay. I've seen exams where students got like worse than random guessing. They get like 5 out of 35 or shit. And I know those people are not studying real hard. So anyway, the old model was that. So if for whatever reason you must miss a bunch of lectures, right? Take the hit. It is what it is, right? You wouldn't have done that great under the old model. And I apologize to the few people who would have come in and aced this and had the discipline and motivation to review the material on their own time. I'm sorry. What can I say? Okay. So there's that. I'll also mention when I do get these, requests for special dispensations, I always wonder, well, I don't always, sometimes I wonder, what would an employer say in a similar situation, right? So I know many of you probably have jobs, but suppose you weren't students at all. Suppose you had, a serious full-time job, and if you told your boss, your boss says to you, hey, everybody's got to be on site 3 days a week. And, I know it sucks. You'd all rather be at home, but we got work that we got to do, whatever. And if you said to your boss, oh man, I live like an hour and a half away. Can I just, not come in? Can I just do everything at home? Is your boss going to thumbs up that? No, right? Your boss is going to say, so sorry, move closer, find a different job, or enjoy your commute, right? That's life. So again, this sort of thing. And some people right now are thinking, oh yeah, but work is different, right? Because they're paying me to be there, but I'm paying to be here. Yeah, kinda. But part of the evaluation process that you're paying for, right? Part of the learning process and building good habits and all that is getting into that frame of mind, right? So here, this is life with bumper rails and, training wheels and shit like that. So if things go really off the rails, nothing too bad happens, right? If you decide to just not do anything in your courses, yeah, you'll fail a few courses. Maybe you'll flunk out, right? I hope none of you ever do. But that's the worst case. And you can try again later, right? If you have a job and you do bad at that job, there's not really that much of a safety net there for you. Okay? So that's all I wanted to say about attendance. So there's that. Now, the other thing, and again, hopefully it doesn't apply to any of you because you're all here. So, second thing, this is actually about the course material. So the other day, remember we were talking about that bit on scholarships and ethics and data mining and how you might have some different variables you're looking at. They're kind of questionable. Yeah, okay. So this brings us into the topic of data quality, which usually I don't have much to say. That's kind of like that's something you talk about later on, like in 410 if you take it. But I brought it up and I figure it's a teachable moment, right? Because life is full of teachable moments. So the issue is this. Suppose data quality basically means, are your data accurate and appropriate for whatever purpose, whatever purpose they're used for? Okay? That's basically what data quality means. Now, suppose you are running that scholarship committee, and you are looking at students' GPAs. Okay. And one of the things that occurs to you is like, hey, maybe we should somehow factor in course difficulty or instructor difficulty so we can get a better apples to apples comparisons, right? Because a 3.9 from a student who took a bunch of easy courses is probably, maybe not as good as somebody who got a 3.8 but took all difficult courses. Okay. So that's what you're going to do. And one of the students the other day, somebody said, well, you could use Rate My Professor for that, because there's, and at the time I was like, rate My Professor is kind of questionable. And I was brief about it because, I had other plans, that day for the lecture, but today there's some time. So I'm going to go with that, right? So suppose you decided to use RMP. I'm not sure if high school teachers are ever on Rate My Professor. I'm guessing not, but no. Yeah, I wouldn't think so. Or some comparable site to get high school teacher difficulty stats, right? Data. Okay. Now, there's a basic problem with this, right? So the first question is, are the data accurate? Well, are they? We'll come back to this one. But, what are some reasons you might think why somebody's reviews, why their difficulty might not be accurate, right? Yeah. Excellent. Well, that's true. Individual differences, and I'll add on combined with possible small sample size, right? So if you have a sample size of like 1,000 reviews, then those individual differences are probably going to balance out, right? And you'll get a good number. But if you have somebody with like 5 reviews, who knows, right? Might tip one way or the other. What's that? Do most people, right, submit reviews? Are they a random sample from the population? No. What sort of people submit reviews? What's that? Did you say weirdos? I don't know. I mean, I'm sure there's some weirdos. Yeah. Yeah. This is called the brag and moan effect, right? Basically, most reviews come from people who really liked the course or the instructor or really did not like the course or the instructor. And, they're either going to say, oh, gosh, thanks for your wonderful experience. I'll do something nice for you. Or, oh, I'm going to show you. Oh, I'll go into RMP and write some shit. Okay. Yeah. So there's that. I'm going to add one other thing. How would you even measure difficulty in a standard way? Okay. What does difficulty for a course mean, right? Does difficulty mean more mental work or more busy work, right? Lots of homework, or does it mean something else, right? What exactly does, and like something else like just the hours required to prep, okay? And does difficulty actually translate into a different grade distribution? Okay, so who here has taken physics? What was the A cutoff in your physics course typically? Ballpark number. It probably wasn't 90%. What? It was 90%. That's impressive. You guys must have been on your stuff. Anybody else? When I took physics here some years ago, I think the cutoff for an A was generally about 60%. All right. Do other people have similar things? I'm thinking this 90% is an outlier, but maybe I'm wrong. Any thoughts? Well, what I'm saying is, does difficulty, even if a course is difficult, right, that it requires more work, if the grade distribution is the same, then at the end of the day, it's not that different, right? And then you might also ask, how much does the grade distribution depend on the students who take the course? All right, so I imagine you have an AP physics course and there's a 90% student average. Those are some students that are pretty good with math and other concepts, right? Stands to reason. So, it's hard to get an apples to apples comparison. So when we talk about data quality, all these issues get rolled into it, right? Basically, yeah, you can go out there and you can find some numbers that say, oh, such and such has such and such difficulty. Is that meaningful? Is it accurate? Is it useful? It's probably better than nothing, right? If you see some instructor whose difficulty is 4.5 out of 5, you can reasonably expect that it's a more challenging course than somebody whose difficulty is 1.5 out of 5. But there's a lot of wiggle room there. Okay. Now, as it happens, several years ago, like 3 years ago, maybe, I was interested in, the decline of education, for lack of a better phrase. Now, I'm going to say, I think we've turned the corner on this, right? I think you guys are more present, more engaged, generally doing better on the in-class questions than, people in the last year. And anecdotally, talking to other instructors, a lot of them feel the same way. Like one of the stats professors said that her students were, doing like half a grade better on the exams. So I like to think things are getting back to where they were pre-COVID. I hope they are. That would be nice. But I was interested in doing some stuff, right? So I was like, is this just me? Is it, are there other things going on? Because I have my own anecdotal experience, but until you go out and look at the whole pool of data, you don't really know. So one of the things I was doing, I looked at instructor reviews relative to difficulty, right? I didn't start out looking at this, but this was a thing I eventually looked at, right? And, it's RMP, so the assumption is going to be that easy professors get better reviews, right? Because, yeah, the sort of students that leave reviews, often they're, they don't want to be challenged too much. So I had rating versus difficulty, okay? And the data plot that I got, so I said, I'm going to look at everybody in the IDS department here. I'm going to see what I find out. And the data plot looks something like this. And it's going to seem like I'm throwing down a bunch of random circles, but in fact, I'm not. There's a deliberateness to what I'm doing here. All right. So this was the initial plot that I got, more or less. And if you draw a line through it, right, it's going to look something like this. But you can see there's a lot of variance, right? A lot of those data points are pretty far from the line, so that you can see that, yeah, there's a pretty clear trend that more difficulty means a lower rating. But for any individual instructor, it's kind of like, who knows, right? Okay. But I did know, because I've been here for like 20 years and I know all the instructors and I know how they teach and I know their personalities. There are quite a few here that I took courses from back when I was a student, right? In multiple departments for that matter, but IDS too. So what I knew is there was one track of 3 professors who, for lack of a better phrase, were definitely phoning it in, right? They were older, they were near retirement, they kind of didn't give a fuck on an epic scale, and their reviews showed it, right? But being inside the system, I knew this. I was like, yeah, okay, they do other stuff, but teaching is not really their thing. Likewise, there was another instructor who is a very good instructor, but he teaches a course that a lot of students are enthusiastic about, and that course is not particularly difficult, right? And so that interesting combination of the course and the material and the students who take it, and he's a good instructor, right? He gets really, really good reviews, right? And this is from a few years ago when I did this, so don't go trying to like do all the math and say, oh, who is he talking about? But, good instructor. And the rest, kind of all in this line, right? Some a little higher, some a little lower. And if I were doing, right, as far as data quality, if I wanted to say, yeah, here's how difficulty looks at rating, if I didn't know those instructors, the predictions would be pretty off, right? But if I'm able to categorize the instructors, I'm here to say, this track, old timers near retirement, they're one track. And, here I might have, super guy, and here's, average, I'll say typical instructors. If I have enough information to track those, suddenly the predictions become a lot better, right? All right, so anyway, this is what I wanted to talk about. Data quality issues happen all the time, right? So in this particular case, if I didn't have that extra bit of information about the instructors, the data, it wouldn't be worthless, but it wouldn't be worth much. With that extra little bit of combined information, suddenly this becomes very useful. right? I can track some stuff. Okay. So that's what I wanted to talk about. Part of the purpose of that was to give people time to roll in, but it was something I did want to talk about. All right. So we'll do this iClicker thing. I'll get that started. We'll do a question. All right. Oh, and to bring it back to the course, data quality is something that we'll talk about next lecture in terms of cloud services, right? Obviously, you would like to pick, when you pick a cloud service, you'd like to pick the best one, whatever that means. But you don't have all the information you would need to pick the best one. So we'll talk about that too. Okay. Let's do 15. We're going to do some review stuff today. So today's question is 15. Once I get this thing going. All right. Oh, yeah, you are. Thank you. Well, kill that one. All right. Yeah. Where's my brain? It's gone. Well, good, because this one failed anyway. All right. I got an exam in my 313 course today, so that's where my brain is at. Might seem like I'm here, but you know, Doug isn't here anymore. Okay. Let's do that one. You're still closing down? Close down for me, and I'm going to open a different one. So there we go. Okay, good. I didn't want to start a new class before the old one was shut down because who knows what that would do. All right, for those of you just arriving, you are lucky. We're just doing the first question now. So, okay, we got a question. The question is number 15. All right, and I'll give you a minute. iClicker troubles? Okay. Well, you're definitely here. Yeah. Okay, what's your name? Allison. Okay, send me an email. So I guess the Mike Tyson boxing match with Jake Paul is back on, huh? Yeah. Any predictions? I don't know, man. I think it'll all come down to one punch, right? Because Tyson might be like 60, but he's still Tyson. I don't know. Man. Okay, we'll call it. Ding, ding, ding. Okay, correct answer. Hey, good. Okay. So, by the way, anything above 50% is pretty good because I know you all aren't studying for this stuff, right? Just saying. So, if you're kind of getting it, well, that's pretty good. 50% means it's about 4 times more common than any other answer. So, that's good. Okay. Anyway, so where we left off, we talked about Amazon as a cloud service, right? And Amazon has 2 big things I wanted. They have other things. They have a lot of services up there. AWS, remember, is their whole portfolio of cloud services. 2 I want to talk about. S3. So S3 is simple storage, right? Simple storage system. System is the third S. So it's a massive key value object storage system. And some of you are thinking, key value object storage system, what is that? Well, I'm glad you asked. So, okay, an ordinary vanilla relational database will generally have a common format for any rows in a table, right? Basically, they all have the same fields in the same format, okay? They follow ACID properties, and that's pretty much it, right? Now, key value store, though, Oh, I guess I could put in, they allow queries involving multiple tables and entire tables being scanned. Okay, so that's really the thing. So a key value store, on the other hand, basically is like, still has tables, still has key fields, right? But the rest of the record can have a unique format, right? Basically, every record in a table can have a totally different build. Okay, now what does that mean in practice? Well, one thing that it means is that queries involving more than one record, right? More than just a lookup are difficult. Because why? Because when you're running a query, you have some parameters that are supposed to match, right? Some criteria. And if the records in a table all can have any unique structure, you don't know where those fields are. You don't know if they're, say, numbers or texts or dates or something else. And you don't know where they are within a record if they're even there. So in a relational database, you can say, oh, I know exactly where to look for this stuff, and it's going to be there. In a key value store, you have to crack open every record, scan through the entire thing separately to find if what you're looking for is even there and in the proper format. Okay. But the good thing is it allows great flexibility. Okay. Which is important if you are allowing many users with diverse database needs to share a single system, right? So in a key value store, every business joining with S3 can have their own blob of data, and it can be in whatever format that business needs. So if business A has an account at S3, they can have a completely different format than businesses B, C, D, whoever else. And the downside is, yeah, you can't do multi-table, you can't do queries across tables easily. You can't do large queries within tables easily. But since every record is its own blob, you don't need to do that. So it's not a free lunch. It's just because there's something that you don't need in that second environment, you can get away with, a little bit of flexibility there. There's a trade-off. Okay, so that's what S3 is. Now, I'm going to talk about the features. So features that you would expect. It's cheap because, it's basically on disk, and disk is super cheap, right? A terabyte of RAM is going to cost you thousands and thousands of dollars, whereas a terabyte of hard drive space at the scale Amazon is working at probably costs them like 20 bucks. Very reliable, very accessible, but analysis capabilities, right? It is a big, important thing that businesses can go to S3 and do the queries they want to do or other analytics right on that data without downloading it. So we'll talk about why. And this is, again, something we come back to a few times. So, simple question. How long does it take to download 1 gigabyte of data? I know some people have downloaded a gig. How long does it take, ballpark? What do you think? 20 minutes? I mean, maybe it does depend, right? If you got like an unstable Wi-Fi connection, it could take 20 minutes, sure. I mean, I'm thinking more like a minute, 30 seconds on like, but I guess your mileage may vary. I don't know. But I'm going to say about 30 seconds. Okay. So if this is just what I'm going to say for this example, but depending on connection quality and hardware. Okay. I'm going to say 30 seconds. Now, suppose, okay, so if 1 gigabyte takes 30 seconds, then how long does it take to download 1 terabyte of data? How many gigabytes are in a terabyte? 1,000. Excellent. Okay. So if it takes 30 seconds to download a gigabyte, it takes 30,000 seconds. Excellent. Now, suppose the business has the maximum size, has 5 terabytes of data in S3. How long would it take to download 5 terabytes? Well, I'll give you that one. 150,000 seconds at that rate, right? Now, anybody know how many seconds are in a day? A lot. I will accept a lot. But the actual number is 86,400. So, which is about half of 150,000. So, assuming 30 seconds per gig, if you want to download that big blob of data, it's going to take about 2 days. You don't want to wait that long, right? This is why it's real important that Amazon offers up those analytics capabilities online so a business can just work with the data that's there instead of having to download it all. Okay. The other one, EC2, Amazon Elastic Cloud. So EC2 is basically where you go if you want to run applications through Amazon, right? So for example, if you're doing big data analysis online, if you're doing transaction processing, any kind of application, you're going to run that through EC2, right? S3 is basically data storage. If you want to do analytics on it, there is that capability. EC2 is pretty much all applications, right? And yeah, it's going to have to work with some data, but the focus is applications. Now, reason for the split, right? S3 is mostly in disk, so it's cheap. EC2, mostly in RAM, so it's going to be more expensive. So you wouldn't want to store 5 terabytes of data on EC2 because basically you'll be paying RAM prices instead of, solid state drive prices. Likewise, you wouldn't want to run your applications on S3 because why? Because it's going to be slower because it's disk based, right? I mean, and it's not even really set up to run applications, but yeah. Okay, so that's EC2. Somebody once asked, why is there an EC2? What happened to EC1? Well, EC2 grew out of Amazon's own internal cloud system. So then when they released it to the public, allowed public access to it, they said, we should give it another name. And somebody said, well, let's call it EC2. And everybody kind of shrugged and said, yeah, okay, fine. So that's what EC1 was, in case you wondered. All right. Now, we'll talk a little bit about cloud. So cloud instance, remember, we covered this before. We covered this a few lectures back, talking about what cloud is. So a cloud instance, right, basically a cloud system, is a bunch of servers that can support a lot of simultaneous access. So everybody accesses the cloud system through one interface, like logging into facebook.com. On the cloud side of things, there's a lot of servers, and people get automatically redirected from the interface to whatever server has, their applications running, and that server can connect in the back to whatever storage media the data is on. Okay, so cloud systems, they can support many connected simultaneous users. Those users can have hardware that's running different operating systems, running other different applications. Okay, so there's a lot of variety. And in a sense, it's like a utility company. So we're gonna talk about utilities. So down here, most of you probably can't see it, but there's a power outlet down there. I guess you can see that one better. And if you wanted to get some electricity, right, you could just walk over to it, put a plug in there, boom, you get electricity like magic, right? Pretty magical. Where does that electricity come from? Go ahead, shout it out, yeah.
Power generators.
Excellent, it's coming from power generators. How do generators make electricity?
Magnets rolling around a big, what do you call those wires? I don't know what they're called, but
yeah, this is good. All right. Did anybody else know that? Couple people? Couple people. This is good. All right. Well, as it happens, I have a little bit of history there. When I was in the Navy, I was a mechanic, but we cross-trained and learned about, electrical and electronic systems. And part of that, I learned how generators work. So basically, yeah, you burn some coal or something. Coal generates steam, which powers a turbine to spin around, goes roundy. The turbine has a bunch of magnets on it. The magnets channel the electrons and give them, as the thing spins, it gives them a push. And that's what sends the electrons zinging down the wire. Okay? Now, the great thing is, you don't need to know any of that to show up and use the electricity, right? I got a plug, there's an outlet, boom, I'm good, right? Same thing with cloud. You don't need to know anything behind the outlet. You can just go to facebook.com and your stuff is all there. You log into Amazon, your stuff is all there, okay? Log into AWS. So this is a wonderful thing. It's a wonderful thing that all of those details are abstracted away. You don't need to know what hardware you're using. Amazon just needs to know what hardware you're using. Okay? So it's like a utility company that way. Now, what? All right. Way back when, right? Back in the 90s, to a certain extent in the 2000s, cloud didn't really start to catch on until about 2010. And even then, there were a lot of businesses with different adoption rates. Once upon a time, pretty much all organizations handled their own data, right? Any servers they needed for their client server setups, they had them on their own premises. Any storage they needed, they had it on their own premises. And there's a lot of perfectly sensible reasons for that. Number one is business as usual, right? Unless there's a strong competitive pressure to do something different, mostly businesses aren't going to do something different, okay? Number two, security perceptions. So if you're a business, you got all your data under your own roof, you figure it's pretty secure. And if you outsource that, you might say, yeah, our IT systems are a headache. We'd love to outsource them to somebody. But guess what? If you outsource that data to somebody, you're expecting them to handle security. And how are you going to know how good at security they are? So that's a concern. Control over system design, right? Maybe your system works pretty well because you have engineers that know exactly what hardware is being used and what configurations. If you put it to somebody else's system, it might not work very well. And that's still a legitimate concern. And finally, accessibility. All that stuff that I talked about, if your data is right there, you don't need to go through some internet connection to access it, right? The connections you can have to link one machine directly to another are way, way faster than what you can have out in the real world on the internet. Because in the internet, there's a lot of delays built into the system, basically. So all those features are there. Those were all part of it. And I guess the last thing worth mentioning is, honestly, stuff didn't change that much, right, from year to year. You didn't have these massive sudden surges of need, right? You kind of knew, yeah, we have so many employees and they're running this set of applications, so this set of servers and hardware will be enough. Yeah, maybe at some point in a couple of years, we'll have to expand a bit. But it wasn't like Facebook is now, where like every day they're pulling up a truckload of hard drives to, store people's new photos. It wasn't like that. So the slow change was perfectly fine, and businesses could pretty much match the hardware they had to their actual needs. But data kept growing, and it all got more chaotic. So in particular, if you're a business, growth is a nice problem, right? As problems go, growth is the problem you want to have. You don't want to have a problem that, people stop buying your stuff and you have no growth or negative growth, okay? But as you get bigger, as you get more data, that brings along some very specific problems. Number one, if your tables get bigger, any kind of analysis you're doing is going to require more computing power, right? Or if you're looking at things in a more detailed way, right? So suppose you want to do better supply chain analysis, and instead of taking like checkpoints at the start and the end of each trip, you do it like 1 minute checkpoints throughout the trip. Those records in that table, they're going to be a lot bigger, right? If every trip is 2 hours long, then you have 120 checks and you just multiplied your data by a factor of 100. Okay, so all this stuff adds up. Storage versus accessibility. Storage is cheap, but providing fast access means that a lot of that data is going to have to be in RAM. We talked about this with Amazon's recommender system, right? If you have a database that has all the records of all the purchases, and you're only using it once, like at the end of the month, so you can tell managers what categories of products are selling well, then that's okay. That system doesn't have to be super fast. But if you have a system that every time a user goes to a product page, you need to pull some information about people who bought this, also bought that, an old-timey disk-based system is not going to be anywhere near fast enough. You have to have that information in RAM, right? So again, that's going to be a lot more expensive. And as the amount of data you have gets bigger, you're going to also have to build in some systems that track what's important right now versus, what's less important. Likewise, all this other stuff, everything involved in keeping data correct, right? If you have multiple copies of data throughout your organization, periodically you're going to have to do cross checks and make sure the value in one location matches the values for the same thing in the other locations. Anytime you're copying data from one place to another, anytime you're transferring data, it's all going to be more work. So I have a couple of links here. This first one got pulled from their site. The second one is behind a paywall. So I'll just tell you, these were some articles from like 2011. And basically they said, yeah, businesses like 70% of big businesses expect to build more data centers within the next year. And 70% of businesses would love to cut down on that expense, right? So that's right at the start of cloud when businesses were saying, you know what, we got to get rid of some of this stuff. We got to pay somebody else to do it. All right. Now, suppose you run a Super Bowl. Oh, we do a question? I'll wait. I'll do a question in a minute. All right. So suppose you're a company, you're running a Super Bowl ad, right? This is your one shot to get your company really in the public eye. And for the 48 hours or so after that ad, you expect your website to get 100 times normal traffic, right? Because, yeah, Super Bowl ad. So your two options as a business, number one, you could maintain your current system, right? You could just leave stuff as it is. Well, if you do that, I guarantee, your system might have enough slack in it to handle 2 times normal traffic, maybe 5 times, maybe even 10 times. But I guarantee you, your system is not built with enough excess capacity to handle 100 times normal traffic. Because if it is, you've been wasting all that money for years. So you just don't have it. So what's going to happen? Your site's going to crash due to heavy traffic. And then a lot of your potential customers who thought the ad was good, thought the product was good, came to your website, they'll be like, wow, it's 2024 and these guys can't even run a website. I'm not going to buy their stuff. So not good. The other one, you can expand the system, right? So you can buy a bunch of extra hardware, right? Extra servers, extra network cabling, set it all up, verify that the system performs well enough. Hopefully it does. Hopefully your testing is good. But best case scenario afterward, your traffic is going to drop to something like normal, right? Maybe you see a sustained increase and you get like 50% more traffic going forward, but most of that hardware that you bought for that one special 2-day event is going to be wasted money, right? It's just going to be sitting around gathering dust. So obviously, neither one of those options is really good. What you'd like to do as a business is basically say, gosh, you know what? It's not worth the money for us to like add that much capacity permanently. We'd like to rent that capacity from somebody and give it back to them after we're done, right? So the other option with expanding the system, right? In theory, yeah, the business could sell all that hardware, but number one, right? A business is probably not in the business of selling hardware. Number two, if they're trying to unload it fast, they're going to have to sell it cheap. Or if they wait to sell it out slowly, well, it's all going to depreciate over time. So there's really no winning answer there. All right. Well, let's do a question. We'll get into a couple more things. All right. So another review, number 18, difference between primary and secondary activities. And go. I'm still thinking about that 90% physics course average. That just blew my mind. Okay. All right. 10 seconds. 9, 7, 5. Ding, 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 ding. Okay, that's it. All right. What's the right answer? C, if you answered C, that is correct. Okay. So remember, primary activities are activities that relate directly to creating or delivering the product. Things like buying components, things like manufacturing the item, things like shipping and handling, right? Sending it to wholesalers or direct to customers, and for wholesalers, sending it downstream to individual retailers. All those things are primary activities. Secondary activities, a way to think about it is they make the primary activities work better, right? And it's not always clear that you're going to make money, right? So if you're manufacturing stuff, you make more stuff, you sell more stuff, you will make more money. If you're putting more resources into HR, well, you're going to add some value for a while, but eventually it's going to taper off, right? So those are secondary activities. With the, oh, that's good. With the exception of marketing, right? And on that particular one, I disagree. I say marketing should be a secondary activity, but you know, yeah, they don't listen to me. So, and arguably should they? I don't know. Okay. So capacity sharing. So the root of cloud is basically one organization has a lot of excess capacity and they share it with a bunch of others, right? So things like idle servers, free network capacity, right? If they have all that, they could run applications for other orgs. They could handle their website traffic. They could store their data, all that kind of stuff. So sharing is actually a really old thing, right? It goes almost back to the invention of computers. So anybody want to hazard a guess about what the first electronic computers were used for? I'll give you a hint. It was for military purposes. It was in the US. First electronic computer. Yeah. Ooh, that is an excellent guess, but that is not correct. But that is a good code breaking is important though. Yeah. You are on the right track there. Yeah. So today's your day. Okay. So the other good guess would be predicting weather. For a long time, that's what I thought it was until I read something else that said, no, it wasn't that. It was actually for artillery, right? Because what you have, if you have such and such a gun with, firing such and such a shell, and the gun's at some elevation, and where's the shell going to land, right? That was basically the issue. So they use computers to do all those trigonometric calculations and figure those answers out. And then they print them up into little tables and give them to artillery officers so they know where the shells would land. So now, eventually, so that's just, that's trivia. If somebody, finds out something else that something else was used first, then I'm all ears. But last I checked, that was the thing. But eventually, so the first computers, they were used for single purpose stuff, right? Because that was a big project to do. But eventually what happened is that businesses would get a computer and they'd use it for something like payroll. And payroll is the sort of thing that it doesn't take all week to do, right? You're not tracking it in real time. It's like Thursday afternoon, you run the computer for a while so you can figure out what people are going to get paid on Friday, right? And then the other 4.5 days of the week, computer's not doing anything. So people start saying, well, what other applications can we set up to run in that downtime? So sharing, is in terms of time, it's been around for a very long time. Second thing, hardware, right? If you were an organization, you had a lot of hardware that you could share. You could store another organization's data, right? Or you could run applications for them. For example, anybody ever heard of SETI, S-E-T-I, all caps? SETI stands for the Search for Extraterrestrial Intelligence. And there was a time when it was a fairly popular thing. If you had a computer and an internet connection, they would send you little bundles of data, and your computer in some of its downtime would run some analysis on that and send it back to the SETI project. So what the astronomers were like, gathering all sorts of radio transmissions from outside. When I say radio transmission, I just mean the electromagnetic waves, not necessarily sent by alien radios, okay? But they gather all that data and they'd send it to you, and then you could help them out by like crunching the numbers on your machines. So in a sense, that was a kind of capacity sharing. But where we're at now is virtual sharing. This is the cloudiest of the cloud models. And you have a lot, you're an organization, you have a lot of excess capacity, but you don't actually link people to particular machines, right? So instead of telling an organization, okay, you'll have this block of 20 servers in our cloud, instead, you'll have the equivalent of 20 servers. You'll have little pieces of applications and storage, maybe on like a few hundred servers or database machines. So it'll be the equivalent of 20 servers, but it'll be virtualized. It'll be broken up into pieces and distributed across many machines as needed. Okay? All right. Now, cloud computing started to catch on around 2010, right? Why not sooner? Because remember, resource sharing had been around for decades, right? Resource, at least since the 50s. So yeah, and storage was always cheap. Storage was never going to be the bottleneck. And server clusters have been available, even like around 2000. I'm sure before that, but in the 90s, University of Illinois, Champaign-Urbana, they had a supercomputer. And if you had like a batch of data that you needed some heavy duty number crunching on, you could, basically upload the data to their system. They'd run the analysis on it. They'd send you back the results. So that sort of thing existed. The single biggest factor was fast connection speed, right? Because until systems like S3 came along that allowed online analytics, if you wanted to have stuff in the cloud, basically you had to upload all your data, and when you wanted it, you had to download it all back. So that was kind of a non-starter for a lot of businesses. But what happened, the data volume kept growing bigger, and cloud services started providing more of these online assistants. And so what you'd see is that business said, you know what, now we can do it. Between the growing cost of managing our own data and the new features being available in the cloud, at some point, a lot of businesses started tipping over to that. So I'll talk about one. This is just I'll build on this, but I'll talk about it first. Okay, Intuit. You guys have heard of Intuit? What's Intuit's product? What do they sell? I know you guys have heard of it. What's that? If you said TurboTax, that is correct. How many of you have heard of TurboTax? Yeah, TurboTax. Okay, so Intuit makes TurboTax, which of course is tax preparation software, right? Some of it's for businesses, some of it's for individuals. So let's talk about the individual one. Is individual tax preparation something that's busy year round? No, why not? Yeah, for most people, right? Yeah, most people, they do their taxes once a year, right? That little 2-month window ahead of April 15th, that's when like 90% of taxes get done. There's a few people that are early birds that start before that, right? But a lot of people don't, a lot of people who have significant taxes to do, they don't get all their forms until, the end of January, early February. So, they can't even do it earlier if they really wanted to. Likewise, that whole window, April 15th to December 31st, right? Only the late people are doing their taxes then, so not going to be much activity. So we'll say, no, that means it's highly seasonal, right? And if Intuit builds a big system that handles, right, that it will be gathering dust for something like 10 months out of the year, right? You don't want that. Intuit doesn't want that. Intuit would be very happy if they could outsource this and they pay double the rate, right? If they found somebody who says, well, the amount that you're going to charge, the amount this is going to cost while the system is active is going to be twice what it costs you, but you only got to pay it for 2 months, right? That's a really good deal. So instead of paying for 12 months of hardware, they're paying for 2 times 2 equals 4 months of hardware. That's a great deal for Intuit. Okay. But there's more. There's more stuff we'll talk about in a minute. Okay. But that's the basic issue as far as, a lot of these things. If you have a system that's only busy part of the year, it's a really good candidate for putting it in the cloud because you don't want to own that hardware. You want to rent it. Okay. The rest of this that I want to talk is really, I'll come back to some of this stuff. So cloud attributes, right? Some other things you might need for a viable cloud service, right? Obviously, flexible contracts. Part of the appeal of cloud is that you pay for what you use when you use it, right? You don't get locked into some contract where you are going to pay for 100 servers, whether you're using them a little or a lot. What you want to have it be is, well, if in the busy part of the day, I'm using like 20 server equivalents, and the slow part of the day, I'm using like 2 server equivalents, you want to be charged for that throughout the day. Okay. And of course, easy, fast, reliable communication in many cases with the ability to do online analytics instead of having to download everything. So there's a bunch of features that cloud services need. Number one, shared resources. What that means, any hardware resource in the cloud is probably going to be simultaneously used by a bunch of different clients, right? You are not going to individually take charge of machines. There are service options where you can do that, but you're going to pay extra for it. Number two, elastic leasing. That just means the amount of services you're renting can rapidly change. You can rent 100 server equivalents one day, drop it down to 2 the next, and that's fine. Metering, there needs to be some way of tracking what you're using so you can pay for what you use. And service-based. Service-based is the one I want to talk a little bit about. So services here don't mean what you think they do. In this event, what services mean is service-oriented architecture. It's in that content, or SOA. SOA rhymes with BOA. Okay. So what a service is in this context is a small, fairly independent application that exchanges information with others through standard interfaces, right? Through standard formats. So we'll talk about this in terms of Intuit. Now, one of the neat things about, you can have, I'm going to mention, you can have SOA without the cloud and have cloud without SOA, but they work really well together. Okay, so that's now I'm gonna draw a picture in a second. So the situation that Intuit had, right? They have hardware that's not busy that much. So they push this system into the cloud, right? They say, okay, this individual tax preparation, platform, we're not going to run that on our own machines because it's too expensive. We're going to put that in the cloud to save a bunch of money. Okay, so they do that. Once that thing is in the cloud, well, in order to get it there, in order for their system to run well in a virtualized cloud system, it has to be broken into services, right? Into those small modular applications. Because why? Because Intuit no longer has control over where those application components will be deployed and how they will be connected, right? You might say as Intuit, well, we have this one big application and we're going to run it all on one big piece of hardware. And because we have control over the system, we know that's going to be the case. In cloud, that might not be viable, right? What they might do is they say, well, yeah, we're going to break this into modules. And so we'll put one module in one part of the cloud and another module in another part. And because the cloud is able to assign modules to its resources when and where it needs to, we don't have to pay for entire server machines. Instead, we can just pay for the little amount that we're using when we use it. Okay, so service-oriented architecture enables that. But there's other stuff. So one thing that Intuit wanted to do, so back a few years ago, I used to write case studies for McGraw-Hill. They were doing some stuff, and I kind of fell into it where they're like, hey, do you want to write some cases? I say, yeah, I'll write some cases. So I learned about some good things like Intuit. They were designing a natural language search feature. Okay, so the idea is if somebody's doing their personal taxes and they want to look up a particular form or instructions on a form or some other bit of tax advice, right? They don't necessarily know the number of the form. If they don't know the number of the form, they got to scroll through some big drop-down menu, right? And try to figure out what the number is before they can properly ask a question and look for things. And that's kind of a hassle. So what they wanted to do is put in like basically a Google type feature where you could say, hey, what's that form that you use for, depreciation of a boat? Right? And then you could go find what the form is and what would be appropriate. So they wanted to embed that in their system. Now, I'll call this TurboTax. I'm gonna make this bigger. I gotta make this bigger. All right. So in the old model, you might have had this natural language search feature as basically like clicking F1 in Excel, right? If you need help, you click F1, and it might be embedded right there in the application. But that means anytime you want to make a change to it, you got to make a change to that application and it might, change how it runs. You got to be careful with what you do. But if this thing is a module, then it's separate, then it's no longer part of the main application logic. It's like sending a request to Google and then Google sends you some information back, right? It's sending it to a separate application. And you have some standard format on this. You have some interface, right? Accepts text input, produces, search results, right? That's the standard format of the interface, standard inputs, standard outputs. And once they've done this, the interesting thing is they have the ability to select from a whole range of possible options, right? So the cloud service they contracted with, they had a bunch of natural language search modules out there. And so what Intuit was able to do, well, they were looking at this from their own point of view, and they're like, how long is this going to take? Because Intuit is pretty good at a lot of things, and they have some smart people working there, but natural language search is not really their bread and butter, right? So they're like, yeah, we could do it. It'll take us a few years probably to, get it going. But because there were modules out there, and because this was implemented in this modular way that didn't really have to be closely integrated with their existing software, they were able to pick and choose from ones that were out there, find one they liked, tweaked it a little bit so that, the search results were more tax specific as opposed to like general, because different terms in taxes will have different meanings from general usage. So they tweaked it a little bit and were real happy and had it up and running and fully integrated with their system in about 3 months. So service-oriented architecture enables this, and again, this could be something that exists without cloud, but it works really well in the cloud because you've already given up that control over how your application is going to be deployed, right? And so it's already modular, so you don't have to do any extra, unbuilding of it. Okay, similar thing. Suppose you go to Amazon, right? So in terms of services, you go to Amazon, you buy some stuff. You and Amazon, and you buy it with a credit card. You buy it with your Visa card. Does Amazon have their own credit card processing transaction, their credit card facility on their own site, do you think? All right, in Amazon? Does Amazon own Visa? No. All right, so what happens? You buy some stuff, Amazon sends the request to Visa, right? And we talked about this before. There's going to be a standard format for that transaction, right? Standard format for credit card information, right? Cardholder info and purchase details, right? What you're buying, how much it costs, product categories, stuff like that. And Visa will send back either a thumbs up or a thumbs down on that transaction. Well, this is not Visa's whole operation. This too is a service. It's a modular application. Now, the nice thing about this, Amazon, once someone has decided on what the standard format will be, then it's very easy to integrate new cards, new credit cards into the process. So, you can process it with MasterCard as long as they meet that standard format. You can process it with Discover as long as they meet that standard format, right? Any different credit card company, as long as they can handle that kind of transaction, you can have them share that same interface. Okay. So again, this is service-oriented architecture. It allows that kind of flexibility where you can say, hey, yeah, today we're doing stuff with Visa, and then tomorrow we're going to bring in MasterCard and all these other ones. And it works, likewise, works for shipping, right? If a package is getting sent out through FedEx or UPS, mostly Amazon was UPS back in the day. But once they have this standard format, it's very easy to say, oh, here's the shipment. What's in the shipment? How big is it? How much does it weigh? When's it going to get to where it's going? How much are we charging for it? What's the tracking number, right? All that kind of stuff can be done through a standard interface as well. So service-oriented architecture, it's something that's out there, and it's really necessary to have because, number one, the relationships between those different businesses are going to change fairly often, right? And having this interface that everything goes through means UPS can change its modes behind the scene, right? So for example, UPS could change its scheduling or it could change its tracking number format, and Amazon wouldn't have to do anything special. They wouldn't have to change the interface. Visa could update how its security checking works for transactions. Amazon doesn't have to do anything special, can still operate with things the way they are. Okay, service-oriented architecture is a big thing. It lets businesses have a lot of different choices about who they're going to interact with and under what circumstances. So it's a big deal. Anyway, that's what I wanted to do. Let's do one more question, and I'll see if I got anything else to cover today. What do I want to do? All right, fine. I'll give you 20. This should be an easy one. I don't know what happened with the morning class. They did not do well on this one, so the bar is pretty low, but I hope you get it. On my way to class this morning, I must have looked a little wiped out because, one of the other professors said, hey, how's things? You okay? And I'm like, yeah, I'm okay. I just, tired. And then another one came along, kind of like the same question. I said, well, you know what? Just once before I retire, I would like to teach an elective, right? I would like to teach an elective where people actually want to be in the class. That'd be fun. Probably won't happen though, but it would be nice. All right. But I appreciate people paying attention. This is good. Okay. I'll give you like what, 10 seconds? 9, 8, 7, 6, 5, 4, 3, 2. Okay, ding, ding, ding. All right, what's the right answer? It is D. Is D. If you said D, oh man, you guys didn't get it. No. Oh. All right. Service-oriented architecture. That services, small modular applications, right? They do a very specific thing, and they interact with other applications through standard interfaces. That means it makes it very easy to connect a new service to that same interface as long as it can handle that interface format, right? All right. We'll come back. We'll talk more service-oriented architecture. The same concept, it keeps coming up. We'll eventually talk about it with APIs. So anyway, all right. We'll see you next week. Have a good weekend. All right. What's happening? Oh,
Alright, so
okay.
would you be able to like kind of estimate what grade hit I'm already taking, if this is not what I got right now? But like this, I was here one day, but only got one question. It's like I missed 2 full classes in like half.
I mean, like I said, there's going to be some forgiveness, but if you want to look at the worst case, right? If you're missing, say you miss 25% of class sessions, you'd worst case you'd miss like 25% of a grade and a half.
Oh,
See what I'm saying?
Yeah.
Yeah. So it'll be more generous than that, but like that's the worst case.
All right, cool. All right,
Yeah.
thanks a lot.
Sure. Hello, what's happening?
Like when I went.
Okay, well, you look like you're here.
Yeah.
What's your name?
Zach.
Zach, okay, send me an email, that's fine. Yeah. Well, that is unfortunate. Okay, what's your name? Min? Okay, send me, oh, you can't send me an email, but send me an email soon. Okay, yeah. Hello.
Does it, like, if I miss a question, does it affect the attendance?
Yeah, people, I don't know who's here if you don't answer questions.
I answered the other two, but I missed like the first one.
If you missed the first one, I would probably assume you came in late.
Yeah. So it doesn't.
Like I said, if you're here every day and you miss a few, you don't have anything to worry about. So, you know, but yeah, I mean, basically people got to yell in the moment. Yeah. Okay. Yep. Oh, hello.
So for this, I can put this alert. This is like I'm having.
Well, your arguments are things you send along to a function call. So VLOOKUP, you are sending in.
Like the letter.
It should be free. Why is there a quote there?
Oh, because that's what I had, but it's not bad.
Oh, the one needs to be arranged. Oh, okay, so you really only have 2 things, yeah. So for a VLOOKUP, you need, just like, you know, check the lab exercise, but you need the value you're sending, and you need the cell range, and you need the number for which column you want to retrieve the result from, which in this case would of course be 2, second column.
Oh, okay.
I was just turning the single sheets. Do we need anything with it?
No, just, you know, have it filled out, and then whenever you go to your lab, just say, zoop, here you go. Yep, yep,
Oh, okay.
Yeah.
So-
Yep.
What is
because
it?
I don't know if you're there or not.
Oh,
Yeah, yeah, yep. Hello. Okay.
Yeah.